Hi, I'm Peter Rowlett.
And I'm Katie Steckles. And Peter, what is today's mathematical object?
Today's mathematical object is a impulse purchase that I bought. It's a 1960s mathematical game called Onsets.
Right, ONSETS.
Yes.
Yes,
Onsets.
That's a very confusing name.
It is, in audio. Yes. We have a module at university where we teach sort of mathematical thinking stuff through recreational maths to our final years. And there's talk of doing this with our first years. So I was looking at first year topics and how they might relate to games. And I put set theory game into Google. A picture of this came up, and these dice were in the picture. And I thought, I would like to own those dice. They're lovely.
So what are these? They've got colours on some of the dice.
And
then
there are four types, right? So the coloured ones are coloured dots.
Yeah. So there's red, yellow, green, blue, another red one, and another blue one.
Correct. Yeah. There are four that are just three dice that are just numbers, but they're not
unconventional. Oh, they are unconventional. So there's two ones.
Yep.
And the 3 is opposite the 5, and the 2 is opposite the 4. And the ones are opposite each other. Interesting.
Yes.
I don't know what that means.
No, I don't know what it means.
There's no 6. But,
and if you compare it to a regular die, somehow the numbers aren't quite... Yeah, it doesn't...
You would expect the 2 to be opposite the 5 and the 3 to be opposite the 4, but they're not.
That's right, yeah.
And then if one of the ones were a 6, they'd be right.
Everything would add to 7. Yeah. And then there are two types of logical symbols dice. There's a red one and a blue one.
So this looks like... If anyone's listening in audio, I've just dropped a dice onto the table. It's got like a prime, like a dash, apostrophe type thing. Got a minus or a 1. A minus, right, good. And then, is it like a union and an intersection?
Yes, and they're underlined so you can tell what way up they go. Yeah, they've got a
little line underneath. So there's a union intersection on that one. And then this one's got subset, equals, and some kind of pointy triangle union and intersection.
Yeah, so it's the subset is subset or equal to.
Yeah.
There is equal to. And then the other ones are empty set and universal set.
Oh, okay, yeah.
But in a language that I don't know the notation for.
I sort of vaguely feel like I've seen that. So it's like a V shape.
Yeah.
Which is...
It's a V and an upside down V.
Yeah. Which one's which? Is V empty set or is V a whole set?
I imagine...
I would like to imagine that the V is the whole set, because if you had it that way up, everything would sit in it, and the upside down V is the empty set because everything's fallen out.
Yeah,
but
definitely.
Let's assume that. Okay.
So they're lovely dice with mathematical symbols on. That's good fun. I then decided to write an article about this and found that the LaTeX packages for drawing dice were wholly inadequate for my purposes, so I wrote a package called Custom Dice, which allows you to put any symbol on a die face. So that was the thing that I did.
The best solution to any problem is write a new LaTeX package. Yeah.
Yes,
this is not the first time Peter's done this.
I've done that too many times.
Yeah.
The other thing that's quite nice in this is there are a set of cards. We will get on to what the actual game is in a minute.
I don't care, to be honest. This is just wonderful.
I'm much less interested in the game than I am the sort of vintage object.
Yeah.
So these have got 4 dots on them, just like the dotty dice have got 4 dots on them, in 4 colours, yellow, green, red and blue. And it's every combination of those 4 dots is represented.
So we've got a single dot of each colour on its own card. We've got sets of 2. I'm not saying that, I'm actually just checking whether they're all there, but I think they are actually. We've got all the sets of 3 and then one card that's got all 4 on. Yeah.
And this one.
And a blank card.
The empty card.
The empty card.
Yes.
Which, confusingly, all the other ones have the word onsets written at the bottom. The one that you would think it would be useful to put that at the bottom to be clear that it's an empty card and not like a mistaken card that's slipped in doesn't have the word onsets at the bottom.
Yes, it's also much cleaner than the others. Which suggests that whoever was using this has not been including that when they've been playing the game, which is fine.
Yeah.
The actual game then has these... This is the playing space. It's 2 cards. And it has all these regions. So what this is a class of games. The chap who made a lot of these games is called Lehman Allen. And it's American. It's in the time of new math, which is this whole reform, Sputnik gave everyone... got everyone very scared, and they decided the solution was to teach set theory to primary school kids. Somehow,
amazing.
Among other things.
Can we do more? No, let's not do more of that.
It didn't work well, and But so it's that era anyway, and he's a law professor, and he's very interested in teaching logic to law students. So that's where he's coming at this from. He thinks, proper formal logic is a great way to teach.
I would quite like lawyers to have a sense of logic.
Yes.
Whether formal mathematical logic has any correspondence to real world logic, I don't know.
But it comes into the whole good at thinking thing, doesn't it?
Yeah,
Rigorous
it's
thought.
a mental skill. Yeah.
So the game is a resource-based game, and he has a few of these, where basically you roll the dice, and what you roll on the dice are the resources that you have available. So then you can put the resources in the resources area on the playing space, and then the game involves moving them to these other areas. So there's an area which is forbidden, so I can make a resource forbidden, so it can't be used. There's one that's permitted, there's one that's required. So I can say, I haven't said what the solution would be, but I can say your solution must include this one, it can't include that one, it may include this other one, all these categories. The solution is you've got to the dotted dice, the coloured dots are the names of sets. So the green dot is the set of all cards that have a green dot on them.
Right.
So
I'm going to rearrange these on the table so that those are all together, which will have no effect to anyone listening, but I will enjoy it.
Lovely.
Carry on.
So a set is a collection of things that have some property that you can define in that way. So you can define these cards as a set. So the whole world, the sort of universe of the game is the set of cards, and the green dotted die draws out the half that have a green dot on them.
Yes, that's what I've established by rearranging them, is that half the cards have a green dot on and half don't, which makes sense because there are two possible states for the green dot on each card.
It is a binary thing.
Yes.
And then you can use things like, if I put the union between the green and the red, for example, I then get all the cards with green on and all the cards with red on.
So,
and some have both.
Mathematically, we could say all the cards with green or red or both.
Yes. And if I'd rolled the intersection, then I would have the ones with green and red.
I don't know if you can hear the noise of me just frantically rearranging everything, but I'm enjoying the challenge.
It's very
okay. That's those.
My glamorous assistant when I'll demonstrate. Yes, to the
nobody,
podcast.
to just us.
Yes.
Everyone else can just hear me moving cards around. I think there are 4 cards that have both green and red.
A quarter of them,
which makes sense. Yeah,
that's all good. The other symbols you identified on here, one was the minus sign, so I can have green minus red, which is all the green cards.
But not red.
But
that's those.
Not the ones with red on. Yeah. And the other one was complement, so you can complement anything.
So it's a prime, but like as in a not sort of thing.
So if you put that after a dot, I can have the red ones, not red ones.
Not red ones,
red
that's
not,
these.
or, yeah.
Good. Again, half.
Yes. And then the game is really, I'm not that interested in because it's a sort of maybe timed, maybe not timed, slightly competitive. You get a group of maybe 2 or 3 players, and you sort of have to move things into forbidden or required or whatever in order to. I still haven't said what the goal is. The goal is that you have to come up with a set name by combining these dice together with the set operations that is some number that you have rolled. So you can roll these numbers 1 to 5, where 1 is twice as likely as the others, and that becomes your goal. There are also rules for combining the numbers, which we might talk about in a minute. But say if I've set myself a goal of 4 and I've got some resources which are set names and set operations, I have to try and arrange them into a name of a set that has 4 elements in it.
Okay, so like the one we just had that was red intersect green.
Yes.
That would work.
But the game really is to restrict things such that your opponent makes a mistake and announces a solution that isn't correct, and then you say, "Ha, you are wrong," because you're trying to train lawyers to be confrontational, and that's sort of why I don't like it.
I've just spotted that on the solution bit at the bottom, it's headed equation, which is adorable, and it's got a pair of set brackets with just enough space to fit dice in between.
Yep.
And on the left it says num, which now I realise means the order of this set, like the number of elements in this set, and then it says equals, and then you put the gold dice at the end of that. Yeah.
So let me talk about, you've got numeral dice rather than dotty dice. The arithmetic for these is, if you put 2 numbers next to each other, that is addition.
Right.
If you put one number on top of the other, that's multiplication.
Right.
And if you turn a number upside down, that is minus it. negates it.
Wonderful.
Yeah. So, if I do something like that, you can tell me what that means.
That is
put 4 upside down 1 above a 2.
Plus an upside down 1 multiplied by 2, so that's 6.
That's 6.
Good.
Very good. Yeah.
This is reminding me of trying to explain to my 4-year-old nephew who was doing some sums. He's got into sums recently.
Good.
And he requested some sums, so we were writing them on his little erasable tablet thing.
Yep.
And he's like, I want level 2 now, because he's very into computer games. He requested level 2.
Right.
So I gave him 2 minus 3. And he stared at it for a very long time, because he's doing it with his counting on his fingers. And if if it's add, you put that many fingers up.
Yep.
And if it's take away, you put that many fingers down.
Yep.
So I explained to him that if you've got 2 fingers pointing up, you put one of them down, put the other one down, and then you put a third finger down. So the answer is 1 finger pointing downwards.
Well, this is consistent with
I just
that.
wanted to see how he would deal with that as a concept. And he was just like, don't be silly, Auntie Katie, go away. Yeah. So we'll see when he comes back to that in a few years at school. We'll see how silly I am then. Anyway, yeah, that's what that reminded me of. But yeah, this is nice. There's a nice little internal set of arithmetic rules going on here. I like it. So if you put a number upside down on the bottom, is that division, or is it multiply by minus that many?
Multiply by minus that. There is no division, I think.
Right.
So one thing I do like about this is that you can play sort of solitaire games with it. So there's a whole booklet full of different things that you can do. There are some Go Fish games where you basically roll a die, and then I think there's ones where you roll 2 dotty dice and combine them with a union symbol, and you have to pull out however many dice there are sort of games like that which are quite nice. Where you have to pull out all the dice that are green and yellow or something like this. But also there's a load of situations that come up in the game, I guess, where you can just solve them as puzzles individually. So here I've put 4 cards out. Do you want to tell me what those 4 are?
Peter's been rearranging my cards on the table. I'm very sad. We've got a set which is red, blue and yellow. Sorry, I forgot what colours were called. Red, blue and yellow, blue and green, green and red, and yellow.
And the dice that I've selected rather than rolled are the 1 numeral, the union, the intersection, and the blue, green, and yellow dice. And so that means that we can only have a goal of 1, so I'm going to put that as the goal and invite you to come up with an equation that draws a card out of here.
Okay, so this is now the whole set of possible cards, and I only want 1 of them. So if we can edit out any long pauses here while I'm thinking, right? I'm trying to think if I put in because there's no cards with yellow and green, but there's no colour that only occurs on 1 card, so that is unhelpful. Blue and green correctly identifies 1 card, but then I've only got union yellow left, and that would add in an extra card. What if I did blue union green, which restricts me to 3 of the cards, which is the blue red yellow, the blue green, and the red green, and then I intersect with the yellow because only 1 of those 3 cards has a yellow on it, and that'll give me just that card.
Yeah. And you would sort of put brackets around that. The manual says to just leave a space if you want to bracket, because there's no brackets. Yeah, that's good.
I'm pleased that I've achieved a primary school level of set theory.
Yes, because it's so hard to think live, I think. But yeah, that's a good solution, and that picks out the first card. You can also then ask more elaborate questions, like you could say, can you give me a solution that just picks out the second card, and things like that, which are then more challenging, which would be, if I did blue intersection green, that would be that card, wouldn't it?
Yeah. But you've still got a union and a yellow, so...
I haven't used the union and the yellow, Your solution used them all, which is much better, obviously, yeah. So I quite like this, because then you can set little puzzles, basically. That's what I quite like about it. But it's a fab little thing, and apparently they would do competitions in America. Apparently some people still do. So people sort of... And there are other games. There's a logic, propositional logic game, but it uses a lot of symbols that weren't the same as the ones that I was taught, so it confuses me a bit.
Yeah, I remember getting hold of a copy of a game called Ergo, which was a quite serious propositional logic card game that had, union and intersection cards. I think there were like 4. I'm going to confuse predicate and propositional logic, but there were 4 kind of statements, A, B, C, and D, and basically you play as one of those 4 statements, right. And there's like 4 lines of reasoning on the table, and you have to make sure that by the end of the game you are true and everyone else is false, which is quite adorable. But it's got like, tautology implies A, and if that, or right. You can do clever things with logic, but then each turn other people get to change what cards are on the table by adding in statements and things. And it was a fun game. It's cool. Deeply complicated, and available as a PDF that you can print yourself if you can't be bothered finding a real copy of it.
Yeah,
it's called Ergo.
Cool.
But yeah, this is a nice sort of simple version. I could totally imagine like a primary school kid getting really into this as well, not just being able to understand it, but actually finding it quite. Because there's something nice and it's pretty as well.
Yeah.
Even though it's slightly old and battered and a bit tea stained in places, yes. it's quite a pretty thing. And I would love to see like a modern update of it, like a real, artisanal small batch board game created version of this. Someone should Kickstarter a version.
Yeah, and my son absolutely loved doing the. Just with the union symbol or just with the intersection symbol, because kids can understand that much, that, and some of them do get quite advanced. I gave us a set of these puzzles. I think I wrote 5 puzzles for my undergraduates, and they played with them because I teach this module about, recreational mathematics, and I have a session on how recreational mathematics is useful in education. So we did this as a sort of little start. I thought this will cover 10 minutes at the start, and like an hour later they were still playing with it. And of course they didn't have a set of the game. I had one to demonstrate with, but they just had my puzzle sheet. So I wrote an article which is in Math Horizons, and the article is free to access. So I'll put a link on the webpage for this episode, so if you want to go and see my 5 exercises and have a go at them, you can find them there.
And a beautifully artistic photo of the game laid out on the table, which I took, is also there.
Definitely.
Okay, so both Peter and I are available on Twitter and on Mathstodon. I'm at Steckles.
And I'm at Peter Rowlett. The podcast is on Twitter at MathsObjects.
And both Peter and I blog at aperiodical.com, which is where you can find more episodes of the podcast.
And if you have any thoughts or suggestions for objects, or just old games you want us to look at, then you can email us objects@aperiodical.com. The music is Funk Game Loop by Kevin MacLeod, licensed under Creative Commons.